Hello friends, in today's video we are going to do hands-on lab on data science with AWS SageMaker. There are 5 major responsibilities of a data scientist. Let's start with the data preparation, training the model, tuning the model, deploying the model, and finally integrating this model with the application. Data scientists spends most of their time in the very first task, that is the data preparation. And that is what we are going to do today. We will take some dummy data, we will transform it and store it into AWS S3. Even if you are from the technical background or from non-technical background, it doesn't matter. Do watch this video till the end because we are going to discuss some services of AWS which doesn't require any kind of a coding knowledge. We will see AWS SageMaker Data Wrangler, which will help you visualize your data, transform your data and store it into the S3. We will also see AWS SageMaker Studio, which is an IDE by using which you can train your model, tune your model, and finally deploy your model. All these activities could be done just by using SageMaker Studio. So do watch this video till end and you are going to learn a lot. Before we go to the lab, let me give you the example that we are going to discuss today. So there is a non-profit organization who wants to promote the government services. The criteria is like anyone, any individual who is earning above 50,000 USD dollars cannot be a part of this, right? It has to be below that. So we have to classify if that person, that individual is earning 50,000 USD dollars or not. That is the only classification. This non-government organization, they does have a data of demographic data, how much education that person has, when, where he is working, right? And very subset of data of what the income of person should be. So now they want to engage some company which is a expert into the machine learning, right? They want them to create some model so that it will do the prediction for the individuals if they would be earning 50,000 USD or below that. So this machine learning company, that the name of the company is any company, that is saying, okay, we will help you with that, but you give us the data which is prepared data. You clean your data and then give it to us and we will build the machine learning model for you to do the predictions. So any data that you will get, it will automatically do the predictions if this person will be earning 50,000 USD dollars or below that. Okay, that is the simple. So here is our lab. This is the data that we will be working on: age, work class, FNL weight, education number, marital status, occupation, relationship, race, sex, capital gain, capital loss, hours per week they work, right? Native country, which country they belong to, and the income. So this income is what we are going to predict. So it is a categorical data, right? Categorical output that we are expecting. So anyone who is earning above 50K or earning below 50K, right? That is going to be our target. Now let's go to AWS and see where our data resides. So if you go to Amazon S3 bucket, inside this bucket scripts data, our data is already residing adult underscore data.csv file. I will go to SageMaker now. So you have to go to Amazon SageMaker, and from Amazon SageMaker you are going to launch SageMaker Studio. Allow it some time to launch. Open the studio. The studio is loaded. You will see page like this. Here you have to click on Studio Classic, and from Studio Classic you will see this running, right? SageMaker Studio. Click on Open. Once you open this, it is going to open the Jupyter Lab. It is going to take some time, so I will pause the video. Okay, now our SageMaker Studio is finally launched. Now what we have to do is we have to take data from S3 and do the preliminary analysis, visualize, transform, and load it back to S3. So from where any company which is the ML specialist, they can take the data. What we will do, we will go to data Wrangler. and we are going to create a data wrangler workflow. What is the workflow? What are the series of step-by-step transformations that we are doing? It will create that workflow for us. Available, you would see there are 9 different sources from where you can take the data. Since our file is residing in Amazon S3, we will go in here, Amazon S3, try to select our file strips, data, and import this file. This is the file that we will be working on. Okay, now as soon as our data is loaded, it is going to show you what our labels are. So our label is age, long, it has these entries 17 to 90, right? Wrangler, sorry, work class, it has a string type, and it has a different type: government, self-employed, private. These are the other different types. Then we have another label which is FN way late, long, education as a string, education number, right? All these details you will see in here, right? Now if you want to analyze it in more better way, go to the analysis section, and you can do data quality and insight report. Here you have to give some name. What we are doing is, let me give just ABC as of now. Okay, that is done, and our target column is what? Income is our target column. That is what we are trying to predict, right? That is our target, and it is a classification. Why? Because we are just trying to classify whether it belong to 50k or 50,000 USD or below 50,000 USD. So it will come into the classification model. Just click on create, and it will generate a report. It will create a summary now of your data. Okay, so here if you see here, it has generated a summary. What it is showing is the number of features or number of columns you have in the data is 15, number of rows is 32561, missing value is 0.935, so we have to deal with this missing values. Duplicate rows, we do have to deal with 0.243 duplicate rows. How many of them are numerical is 6, categorical are 7. So categorical has to be converted to the numerical, right, in order for machine learning to understand it. Let's scroll down. So in the summary section, you will see all these details. It will show you the duplicate rows. Data wrangler detected 0.243 of the data and duplicates. Okay, so it is showing you how many duplicates are there and the count. Okay, so duplicate count is 3. With this entry, there are 3 entries that are duplicates. So we have to deal with duplicates. So all these entries are there. So with this entry, age 18 private, there are 2 entries. With 28 and private, and with this FLG master, it has 2 entries, right? So these are the duplicates in there. Anomalous samples also you will see. Data wrangler detects anomalous samples using the isolation forest algorithm. So this algorithm also you have to remember, like it is going to use the isolation forest algorithm, right? And this anomalous samples, it will give you what outliers do you have, right? How many outliers it's in there. You can find those details in here, and it will give you the target column, how many entries are there. So for below 50k it is around 24.1, and above 50k it's 76.1. Quick model analysis it is doing, confusion matrix it has created, and the feature summary. In the feature summary also you will get, so see in the missing values it is showing, okay, the occupation has the missing value of 5.66. you have to deal with this. Missing values has to be removed. Work class has 5.64. Also I believe the native country has 5.70 or 1.79 missing values. Now it is showing you the relationship between them. So once you run this, you will get all this analysis. You can do it. Now let's do one more thing. So we have done the initial just analysis, right? We will also try to find the target leakage for this. Go to data flow. Once you go to data flow, you have to click on data type and go to add analysis. what we want to do is we have to find the target leakage. What is target leakage, guys? Target leakage is nothing but if you have a target and if the same kind of a data is available in the another column, right, with a different name or something, so it is going to conflict in predicting the target, right? So we don't want something duplicate it's in there, so we have to find the target leakage. Go to target leakage. What is our target? Our target is going to be income, right? Let me give it some target label. I will give, okay, target label. How many features that we have? We have total 15 features. And what is our problem type is a classification, and the target is what? Income. And we are going to run this. Finally it is executed, and what it is showing is like the provided predictive matrix is ROC computed individually for each column. So it is calculated for each column via cross validation on sample of 2038 rows. So 2038 rows has been used to in order to find this target leakage. A score of 1 indicates predicting perfect predictive ability. So anything with this upper side, right, the relationship, this has a good relationship, right? So it is going to help us with the correct prediction. And a score of 0.5 indicate that the information on the column could not provide on its own and any useful information toward predicting the target. So anything which is near 0.5 is not contributing anything. It is not going to help us in predicting the correct prediction. So we can remove this entries, right? So this is the analysis of the target leakage. With target leakage we could find out like this, two things can be removed, right? Let's do one more analysis. Let me try to do the histogram. Okay, I have to create a histogram, and I will give a name again, hist. I will say hist. X-axis could be income, right? And color by, let's consider race, and phased by sex, and yeah, try to run it. So this is what it is showing. So you have considered income as x-axis, right? And you have differentiated it by female and male, and you have considered income. So what is the count of records available in your data, right? So this is the analysis that we could draw. Now let's work on the transformation, right? You have to go back to the data flow, and now go to the data type and do a transformation. Let's start with the transformation. So this is the initial analysis only that you have done so far. Now we are going on the transformation. Now first of all, what we saw is like we do have the duplicate columns, we have missing values, we have duplicate values, and the labels that we have, it has names, right? So that names could have space in the front or in the end, right? We have to deal with that too. Now let's start with, first of all, removing the columns that we don't need. What you have to do is you have to go to add transform, right? And we are going to drop the things that are not needed on the columns. So I will go to manage columns and drop columns. Which columns that we do not need, right? We saw FNLWGT when we ran the analysis. We saw this two are not going to contribute, that is FNL weight and the native country. These two are not going to contribute in any ways in order for the predictions. You just have to click on preview, and on the left hand side you would see that is removed, right? Those two columns are now removed, right? Click on add. So this is the very first transformation that we have done. now we have to, so columns are removed. Now we also have to drop missing values, right? So in the again add transformation, you have to now search for the handle missing, and what we are going to do is drop those missing. So any entries that is missing, we are just going to drop it from the data we had seen, like occupation and work class. Where is the work class? Okay, this two has the missing values. Review it. It is going to drop the missing values for these two columns, which has the missing values as we see in the in our initial analysis, right? Add it. So we have taken care of columns that are not necessarily missing values. Now we also have to take care of the duplicates, right? We again have to add transformation, which will say manage rows, right? So okay, yeah, transform, and what is it? Drop the duplicates. And drop duplicates, we are not going to select any column, right? Any duplicate sit in there, just go ahead and drop it. So we are simply going to add it, and this is going to add drop the duplicates, right? Now let's take care of any of the label which has space in the front or in the back, right? We have to add again one more transformation. Let me select that. Okay, so we have to do the format string, right? Transform to what? Transform to strip left and right, right? If there is any space, just strip it out. And whatever the strings that we have, right, string labels that we have to implement it for it. Click on this, whatever strings we have. So these all are the strings, right? This is the long, and these are the strings. 1 3 4 5 6 7 labels, 8 labels we have, right, which has the string value. Characters to remove, space, any space is there, we have to remove. So just add tab there, give one space, and just click on preview. So it has removed any space in there into the labels and got it removed. Click on add. So as of now we have seen 6 transformation. Now let's solve our target is what? Income. Income has values in which format? Greater than 50k, greater than 50k, or lower than 50k. Okay, now let's transform it. The goal for the model is to determine whether an individual is likely to make less than 50,000 USD. The target column already includes the information in the string format. Okay, so we have to transform this into zeros and ones. So anything above 50k should be 1, and anything which is below 50k should be 0. Okay, now let's add that transformation. So we want to our income, that is target, to be in the zeros and ones, so the machine learning model could understand it. We are going to add transformation, right? Here we will do search and edit, not find and replace. Okay, and the input column, what we are going to, our input is the income. Okay, and the pattern, what is the pattern that we are working on? Greater than or equal to 50k. Okay, if anything is greater than or equal to 50k, replace that string with 1. Getting my point? And then we will do preview. Now here you would see See, it has converted, so greater than or equal to, it has converted to 1. Now we have to add this, we have to add another transformation too. So anything is below that 50k, it has to be 0. Find and replace, input column would be income, right, and pattern would be less than less than 50k needs to be replaced with 0, right. Preview and add it. Okay, if you go in here now, if you go to income, you will see everything is in the ones and zeros, ones and zeros, ones and zeros, right. So this kind of a transformation we did so far. Now we have to handle the outliers. How you are going to handle the outliers? In our previous analysis, when we visualize the data, we have found there are outliers in the capital gain. Okay, so we have to remove the values from the capital gain because there are outliers there. So what we will do is we will try to do the handle outliers. Okay, here in the transform section, what we are saying is minimum and maximum numerical outlier. Anything which is between 0 and 80,000, that is okay, but anything above that or below that is an outlier, right. So I will going to select a column which is that is a capital gain. Okay, we will select the capital gain and no need of output column, but the fixed method would be what we are going to remove it. And what is the upper threshold? Upper threshold is 80,000 and the lower threshold is 0. Okay, once we do that, you just have to click on preview, and it has removed the outliers. Just click on add. So this kind of all these transformations that we have done so far, dropping columns, drop missing, drop duplicates, strip left and right, find and replace substrings, this is for we did for the income. And now we have removed the outliers. Now one more thing, now we have to perform the ordinal encoding, right. Why? Because in the education num and education column, you would see in education num we have entries 13, but it is not starting from 0, right. It is any random number starting from 9 to 15 or something from C3, right. So we have to make it a random, like from 0 to 13 it should be there, and education string, it has to have some values, right. The bachelor, we will give some numbers to it. How we will do that? We will add the transformation. What kind of a transformation it would be? We will use encode categorical, that is the transformation. And the transform section, what we are using in ordinal encode, right. So how ordinal encode work is like the ordinal encoder turns categorical feature into a numerical format. The labels are transformed to integer values based on their ordinal relationship to each other. I will give more details about this in the description as well, so you can create and go through it. What happens is in the education num section, right, column has the values that is ranging from 9 to 13, right. So we have to make it from 0 to 13, right, that kind of a sort. Now we are going to apply ordinal encoding. In the input column, we are going to select education num, education, and the occupation as well. If you see the values in here, education has bachelor, higher school degrees, other details. And in the education num, we have the entries are not starting from 0. What about the occupation? In occupation, we have the white collar, blue collar, different these entries, right. So we have to convert it into a number, right. And for invalid, this one, replace to none, instead of replace to none, we will say skip and preview. So by using this, what exactly we are trying to do is we are trying to change the entries to the numerical format between 0 to the total number of categories that we have. If you go in here now and check for the education, see we have the range of 0 to 5, right? We have changed it this value, so whatever the bachelor degree or anything was there, it has converted to the 0 1 2 3 4 5, that kind of a stuff. In education number, same thing has happened. It has converted from 0 to 15, the numerical format which is understand by the machine learning model. In the occupation, same thing has happened. We have converted the occupation from 0 to 3, right? Earlier what our entries was, you will see in occupation we had the white collar, blue collar, profession, services, different entries was there. So we have given number to each of these entries, right? So this is what we have done, and now we have to click on add. Now we also have to perform one hot encoding on the entries, right? So ordinal encoding, what happens is, in ordinal encoding can introduce bias in the model if used incorrectly. If a column contains labels that have equal values like sex, one hot encoding is needed, right? To turn the labels of column into the columns with labels 0 for false and 1 for true. Transform the sex column in two columns, one for male and one for female, using the one hot encoding. Now let's do that kind of a transformation, and this transformation we are going to implement for rest of the columns, right? In order to do that, we have to again go to the encode categorical, go to encode categorical. Here, instead of original encoding, you are going to select one hot encoding, and what all columns we are going to select here, there will be the multiple ones. Now whatever has these values, now the marital status, race, relationship, sex, work class. Okay, we are going to convert it into the one hot encoding. As of now, you can just go ahead and check this. What is the entries for the marital status? So age is into the numerical format. Work class we are changing because work class has this increase, and then marital status has this not married, married, and different entries, right? String, relationship has different entries, not in family, husband or different. You can scroll just down just to find what all entries are there. Race we are going to change. We will say just skip this, and we will apply. And this output style, this shouldn't be vector, right? It will give you different entries. Select a column and then do the preview. Okay, now go ahead and check your data one more time, right? So age we are in number, education we have entries 0 to education num we have entries occupation. Now what happened in this, right? Capital gain is okay, capital loss is okay, hours is okay, income numbers okay, marital status. Now once we apply this one hot encoding, what happened is the marital status, different columns has been created. Marital status married is in the float format, so only zeros and 1. For married, it will be either 0 or 1, right? Marital status not married is a different column is created, 1 or 0, right? For same column, marital status separated, different column has been created. Marital status widow, different column. Same thing for the race. So if the race is white, there is only 0 or 1. Race black, 0 or 1. Same thing for different entries. Race Asian, Pac, Icelander, 0 or 1. Okay, so this is how we have converted each and every column into zeros and 1, right, depending upon the category. So we have created different columns altogether. Same for the sex, male or female. If it's a male, 1. If it's a female, 0, right? So this is how we have converted each and every categorical data into zeros and 1s. Now last thing that is pending is moving the target column to the front. In this lab, we are going to use XGBoost algorithm, which has the prerequisite that the target column should be into the first, the very first, and that is what we are going to do now. Let me add this. We will go add transform, manage columns, and in the transform what we are going to do is we will say move column, move to start, that is correct, column to move, and what is that column? It would be income. Where is it? Income column. Move this income column to the front. Now if you go to front, you will see income has become the very first column added. So this all transformations that we have added so far. Now we want to export this transformation to the S3, right? This all the transformation has to be stored into now S3. So from where the machine learning company, which is any company that can take the data and apply the machine learning algorithms, right? So how many transformations that we have seen so far, and I will be giving the step-by-step guide for this, guys. So drop columns we have seen, drop duplicates, drop missing, string left to right, replace, find and replace substrings, minimum and maximum numerical outliers, ordinal encoding, one hot encoding, and moving the column to the first. All these transformations we have done so far. Alright, now let's go to data flow. Now you will see your data flow like this. So that is what you have created so far. So you took the data from S3, you visualized your data, and from here you saw the histogram, right? Data quality and everything. And now all these transformations, dropping column, drop missing, drop duplicates, string left and right, finding and missing, all these transformations you have implemented so far. Now we have to export this data. So there are two ways. Either we can use add destination, or we can do export to. If when you do export to, you have all these features. And when you are planning to do add destination, you can put it to Amazon S3. But if when you decide to, a destination node tells SageMaker Data Wrangler where to store the data after you have processed it, right? So if you go to destination node, right? So what this happens is a destination node tells SageMaker Data Wrangler where to store the data after you have processed it. After you create a destination node, you create an Amazon SageMaker processing job to output the data. Before you use the destination node, if you want to use it, you need to create a split data transformation to split, right? And that is what we are going to do now. So we have to split the data before we add a destination. How we are going to do it? So splitting the data, I believe you would be knowing, like once you have the data, you have to split it into the training, test, and the validation, and that is what we are going to do. Go in here, again add transformation, and add split. Now we have to split the data. Okay, we are going to split the data, random split, that is correct. We have to randomly split the data. In the train database, we want 0.7%, means 70% of the data will be in the train, and in the testing we want 20% of the data, that is correct. And we want to add one more split, which is the validation split. In the validation, we want 0.1% of the data, that is 10% here, 20% here, and 70% will be there. Error threshold, we don't want to enter anything, just click it and add a preview. So once the preview is completed, you can see what data is there and what's in what. Here you will see the drop downs, right, of these three different databases. Okay, now the data is split into the different train. This is, so it will show you the train data, how much data are there, test and the validation. Okay, now go back. So you have already created 3 different databases where you want to split this data. 70%, 20% and the 10% of data will be going there. Right, now run the validation. Once you run the validation, it will give you, okay, 0 errors has occurred. So all these transformations that you have done has no problem at all so far. Right, everything is functioning good as needed. Okay, let's split the data. Now we have to random split. In the train it will be 70% of the data, in test it will be 0.2, and we have to add one more, which will be the validation. Okay, this is the validation, and the split percentage will be 0.1, that is the 10%. Error threshold, skip this, there is no need of this. Right, and then we will do preview. Once the preview is done, don't forget to click on add, otherwise it will not save. Okay, so once the data is split, you can see what data is there into the train and what is there into the test and the validation. All these data you can see. Click on add. Now once you click on add, right, this 3 different data sets are created. Right, this is train, and this is test, and this is validation. Now in order to now you have split the data, right? Now just run the validation. Okay, now validation completed. So all these transformations are correct, no problem has encountered, this is done, no error has found. Now you just have to click on this and you have to add the destination. Right, Amazon S3 destination you are going to add. You have to give it a name. Right, what is this? A train, adult underscore data underscore train, that is what we are adding. Go to the Amazon S3, what will be the destination? Right, we have to go to the lab data bucket, script, data, and what is it? Training data, right? Select. Okay, number of partitions, how many partitions do we want? Only one partition, no need of anything else. Add as a destination. Okay, so we added the destination. Same thing we have to do for test, and same thing we have to do for validation. Add destination, go to Amazon S3, test, destination will be go to this, scripts, data, test, and select add destination. Same thing we have to do for validation. Add destination, Amazon S3, adult, validate, adult, data, validation. Okay, go to browse, scripts, data, scroll down, select validation, select add destination. Okay. Okay, now all these destinations has been created. Now you will choose on the data flow to create a job. Now you have to create a job. Nothing to touch here. Just simply go scroll down and configure job. And now we don't want two instances. Okay, let it go. Click on create. Job created successfully. And now if you want to see this, you can copy this and paste in here, and you will see the progress of the job. Now our job is completed, and we are going to S3 buckets, and we could see the train and test data sets are now created, which we are going to provide it to the machine learning company to create a machine learning algorithms on it. I believe you have watched the complete video, and you have learned how to transform your data before providing it to the machine learning model. You can use AWS SageMaker Data Wrangler, AWS SageMaker Studio to transform your data. So no code is needed. It is just you have to drop or import your file and apply your transformations, visualize your data, whatever you want to do, you can do it from Data Wrangler, and just export it to S3 or any other different destination location. So no coding is needed, guys. Continue your learning.